Hello, everybody, and welcome back. Today, I got a good update for you. I've been working pretty hard getting through some difficult errors. But today, so where we left off last time was placing a limit buy order based on what data we're getting from the sports book, right? And so initially, I thought sending an API call to the Q market endpoint for Alpha Arcade would set up an order and send that order to my wallet that I pass to that API. However, that is not the case. I realized that I have to build out this transaction call with AlgoKit, right? And so I had to do some digging and look into really what is the application call that is built so that I can create a escrow and buy order. So here's a script that I have been working on, and this essentially has a function that creates an escrow limit buy order on Alpha Arcade. And so I'm going to go through it, and then I will show you, and I'll run it and show you that it's working, and then show you that the order on Alpha Arcade and kind of the ins and outs of the transaction on Laura the Explorer, which is a transaction visualizer that Algorand has built. And here we go. So you have a couple helper functions. So let's start here. This is check asset opt-in. So essentially this is checking if the wallet that I am specifying in the argument call or the function call, if this address has the assets that are needed in the transaction. So say I'm buying a yes share of for the Red Sox to win. That will check that I am opted into that yes asset. And if it'll return it true or false, and based on that, I will opt in or not. If it's true, then I won't opt in. If it's false, then I will implement functionality to opt into those assets that are required. Another helper function that I have here is calculate fee. This is a formula given or taken from Alpha Arcade. It's just kind of calculating the fee based on the quantity of shares, the price per share, and then a fee base, which is a constant that is provided from Alpha Arcade. So here's the meat and bones, right? This is the create bet function. And so what we're passing into this function are a few arguments. And here we have is buying. So this is true, right? Because we're creating a buy limit order. The quantity. So this is how many shares we're buying. So the price per share, and then the position, yes or no. And so what we're first going to do is we're going to get some of the constant values that are associated with this buy order. Right now, they're just constants that I'm loading in from the environment file. But eventually, when I integrate it all together, I'll be fetching these values from Alpha Arcade so that I don't have to go in every time and type it in and rather just put in the one market app ID for the market that I want to run this bot for, and it'll get all these like the asset IDs and such and the market address automatically. And so I don't have to go in and specify all of these variables before running the bot. And so make sure I have all those variables for now. So this is where we connect and set up the Algorand client. So this is really this is the client that interacts with the Algorand blockchain. So a client that brokers easy access to Algorand functionality. So here we're connecting to the Algorand mainnet, getting a client. And so this is essentially what we use to send transactions, right? And then we get the private key from, the private key is created from the 25-word seed for your wallet. And so we generate that private key, get the address from that private key, which is the address of the wallet, right? And then this is a signer. So this is essentially when you create every transaction, you have to assign the transaction with that private key, right? And so to make sure that you are the one allowing that transaction to happen. And so this is represents a transaction signer for an account that can sign transactions for an atomic transaction group. And this atomic transaction group is what we are going to be constructing in this script to send and sign on the Algorand blockchain so that it creates that buy order. Um, so here, just printing a few stuff. Here I am ensuring that these assets are opted into, right? And then, so we're going to opt into, we're going to see if we're buying, we're going to be opting into, if we're buying and the position is 1, which is yes, we're going to opt into the yes asset. If we're buying and the position is no, then we're going to be opting into the no asset. If we're not buying, we're going to make sure that we're opted into USDC, because essentially if we're not buying, we're selling one of these two yes or no assets and we'll be getting USDC back. So in our script, we need to make sure that that account has been opted into that USDC. So here we go. We check if we check that this sender address has opted and the opt-in asset based on what we're doing are all set. And if they are not, if we're not opted in, if this returns false, then we will be opting into that asset, right? And so that is a simple asset transfer of quantity 0, and that is just a way of opting into that asset. So we'll wait for confirmation and then continue once we have a successful opt-in. And so here we go with the actual construction of the atomic transaction. And the atomic transaction composes of 3 elements, essentially. It's when we're buying. We're paying a set amount of algo to an escrow account. And this is essentially paying for storage on the blockchain, right? So here we go. So we'll create the atomic transaction composer. This is what we'll be adding each transaction to. And so atomic transactions are essentially a bunch of transactions in one group. And if one of those transactions in that atomic group fails, then they all fail and none of them go through. And so this is really a very powerful aspect of Algorand, is that they have atomic transactions built in to the primitives of the blockchain. And so like I said, we're going to be adding 3 parts to this atomic transaction. One is the payment for the storage on the blockchain. The second is a asset transfer. And this asset transfer for when we're buying is the USDC. And so this is the price times the amount of shares plus the fee, right? And so right now, this is going back to the payment transaction, this is the amount of algo that is needed to store the escrow account. And this is in micro algos, so it's essentially 0.9676 algo. So it's less than an algo. And also, once you opt out of this application, you can get this algo back. So it's not like you're paying it out and never getting it back. You can get that back once you are finished with this transaction. So the second one is an asset transfer. And so this is essentially what we are paying for with this transaction. So because I'm buying, I'm going to be sending USDC to an escrow account because I want to buy that asset. If somebody else buys that, they'll send the asset and that USDC will go to them, right? So I am basically paying for I'm putting an asset in escrow in case it gets bought. So this amount is essentially the price of the share times the shares plus the fee. And so this is where we calculate the fee based on the quantity, and price and fee base. So this fee base is 70,000 or 0.7 units, and this is a constant based on Alpha Arcade. This will equal this, and so we will be sending the price, because right now I'm just buying one. I'm going to be editing this to be price times quantity, because that's how much we are going to need to transfer to buy that many quantity of bets, right? And so, or shares. So price times fee right now, because quantity is 1, we're going to be sending it to the application address, this is the market ID for that application on the blockchain. And so associated with that application ID is an application address, which is going to be where I send that USDC asset to. And so then I add that transaction to the atomic transaction composer. So that's the second one. The third one is the actual application call. And so this is where we have to set up the arguments of the smart contract and specify those arguments, and then add that method call to the atomic transaction composer. And so right here we have the app ID and then a method. So this method has to be created, right? And so here you can see it comes with a name, an arguments in this case, and a return value. And so this is where I got caught up a lot, was because these were one out of order. So if you're creating a method to call an application, make sure the arguments are in the correct order, and also make sure that they have the right type. And so this is what we are specifying in the application call. So here you can see this is the price of each share, right? In this case, I'm going to be buying a 73-cent share. This is the quantity. This is 1 for me. This is the slippage, and then a position, so yes or no. So we built the method with the arguments, and then down here we can see we specify the method, and then we specify the method arguments here. So this is the amount in micro USDC. That's the price, right? That was the first argument. The second argument was the quantity. Remember, we're using micro units. The third argument was the slippage. I don't really care too much about the slippage right now. I just would like the order to go through so that we can see it. And then this is the position, right? So 0 is no, 1 is yes. And right here is away and home, because based on what I get from the sports book, that's kind of the yes and no. So right now I'm buying no. And then the foreign assets are all the assets in the application, which is the USDC yes and no asset, right? And so here we will be taking that atomic transaction composer and executing it with the Algorand AlgoD client. Then we'll be the 4 right here is how many seconds to wait rounds. So how many rounds we wait to see maximum number of rounds to wait for transaction confirmation. And then if it fails, it will print the atomic transaction composer error right here. And if it succeeds, it will print the successful transaction IDs. There will be 3, if successful, there'll be 3 transaction IDs, because remember, we're doing 3 transactions. We're doing a payment for the algo, for the storage, an asset transfer, which is the USDC yes asset or no asset, and then the application call. And so we'll get 3 back, and then I will kind of show you the structure of those transactions with those transaction IDs. So here this is where we're calling that create bet method. This is the function that we just went over and defined above. So we're going to be buying one share at 73 cents for no. And I will be adding in an argument here for market app ID, because we need to know, the function really needs to know what market we want to buy, really. And so right now I'm just specifying that, getting those values from the environment variable file, but eventually I will add another argument here and extract this out into a different main function that I can continuously easily so that I can easily specify which market I want to buy. So let's go ahead and run this application. So I'm going to run, and I'm going to put in some breakpoints. And so this like stops the application and kind of shows you some of the variables and lets you debug a lot easier. And so let's run. And so, yep, so it's starting to run. All right, here we go. We stopped at this asset transfer. So here you can see the sender address, market app ID, couple of stuff. This is the memory address of these objects. But here in the console, a couple print statements have been executed. Here we have the sender address, market app ID, and the specifying what we're doing. So we're buying no tokens, quantity of one. This is micro units, so one at 73 cents. And this market is at this market app ID correlates to this Russia-Ukraine ceasefire market. And where you can find that market ID is in the network. So when this data is fetched, you can see that there is a get market with the market ID. And then down here in the response, there is a market app ID. And this is where you can get that value. There's a lot of other information here that is used throughout to get the data. But right now, so we can see in my portfolio, I don't have any orders, right? So that will change hopefully when I continue this application call. So let's try it out. I think I don't have any more. Yep. Okay. So it's submitting group now and success. Perfect. So so I should now, because it's success and that atomic transaction of all those three transactions together submitted successfully. And so I should now, when I go back to Alpha Arcade, see that order in place for 73 cents buying no. So here we go into orders. Might need to refresh. Oh, that's odd. Okay. So now we can go into orders and voila, we have one buy order for 73 cents for one share for no. Perfect. So this script seems like it's working correctly. So I'm going to show you a little bit more about what that transaction really looks like. And this is Laura the Explorer. This helps you visualize the transactions that we are submitting. So I'm going to copy this. The third one is the application call. And so, yep. So this is the transaction ID. So perfect here. We can see the outer transaction is the application call. This creates the application, pays half of that fee to an escrow account. I think it's half because half of it goes to the yes and half of it goes to the no ID. And then when somebody else buys that order, that space on the blockchain that is held until those assets are canceled and returned, and then you can get that escrow payment back. So this is the application call, and then we have the transferred USDC, and this is remember, this is the price times quantity plus the fee. And so we have a 73 cent for one share. So 73 plus the fee, which is less than 2 cents, almost a cent and a half almost. And so, yeah, so this is kind of cool. It helps you see, these are the application arguments in a encrypted format. I'm not really sure how to view those these are the foreign assets I specified, but I'm not sure how to view these as non-encrypted, but that's okay. But yeah, that's all I have for you today. The next steps, I'm going to be creating another function like create bet, but to cancel orders. And so if I have an order open and the odds change, I want to be able to cancel those orders. So my next step is to create a function that will cancel bets. And so that's my next step. I will be yeah, so my next step is to create a cancel open orders function. And then after that, I will be combining everything we've done so far together to try to create a final product bot and put it to test. And then after that, I'm going to test it and I'll kind of show you guys the results. And then I will be revising it based on that. And so like I said, this is work in progress. I'm just kind of going through it with you guys to show you what I'm doing. Yep, so that's all I have today. I will be coming back to you with a cancel order function, and then we'll bring it all together. Thanks for listening. Take care.